Okay, then we'll continue. So the pitch circle radius of pinion first I can calculate it by small r, that is mt by 2, and you get the value of 50 mm, and the pitch circle radius of the wheel, that is by capital R, that can be calculated by mt by 2. So you get that is as 100 mm, and then addendum is 5 mm. So you can calculate the radius of the addendum circle on pinion as well as wheel. You get 55 and 105 mm. Okay, so you got R, then capital R, and then small r a, and then capital R a. So next you can calculate the length of path of approach. You know the formula. So r a square minus r square cos square phi minus r sin phi. So this from this you get path of approach as 12.65, and then the path of recess you get 11.5 mm, and total length of path of contact you get 24.15, and the length of arc of contact you get 25.7 mm, and the angle turned by the pinion. So last class I had given you the formula. So if you multiply by 360 degree divided by circumference of the pinion, so you get the angle turned is 29.45 degree. Okay, so this is the answer. Then the maximum velocity of sliding. So omega 1 is v by r, and omega 2 also this v by r. So if you solve this, you get omega 1 as 24 radians per second and omega 2 as 12 radians per second, and the velocity value omega 1 plus omega 2 into kp, if you take in millimeters, so you get 455.4 millimeter per second. Are you getting the same answer?
Yes, sir.
Same answer?
Yes, sir.
Yes, sir.
Okay. So here the maximum velocity of sliding formula, you have to take omega 1 plus omega 2 into the value which is higher. Okay. Here what you are getting, kp is greater than pl, that is path of approach is greater than the path of recess. So whichever is higher that you will take. So here we will take it as kp. Okay. So generally path of approach is higher value. Next, take the next problem. So in this problem you can see two involute gears in a mesh having the module of 8 mm is given. So module is 8 mm, and the pressure angle is 20 degree, and the larger wheel has 57 teeth, and whereas the pinion has 23 teeth, and if the addenda on the pinion and the gears wheels are equal to one module. So if addendum is nothing but one module, so you have to find out the contact ratio, then the angle of action of the pinion and the gear wheel, and the ratio of sliding to rolling velocity at the beginning of contact, at a pitch point, and then at the end of contact. Okay. So with the given data you can try to solve this. Okay, so you get the radius as 228 mm, and radius on the addendum you get 236 mm, and for the small r you get 92 mm, and RA you get as 100 mm. Okay, so I think you got these answers. Shashank and Vinay.
Yes, I got, sir.
Okay. So next, if you want to calculate the contact ratio, so it is nothing but arc of contact divided by circular pitch. So that will be nothing but path of contact divided by cos phi into 1 by pi m, that is circular pitch here. and path of contact is nothing but path of approach plus path of recess. So entirely I can use this thing to calculate the contact ratio. So together I can calculate, or you can split wise you can calculate separately also. So here all done together, and when you solve it, you should get the contact ratio as 1.68. So this will be the answer. Okay, anyone got the answer 1.68?
Yes, sir. 1.6833.
Okay. So you understood the procedure, how to calculate the path of approach and path of recess and total length of path of contact, then arc of contact and contact ratio. Okay. So like this, little bit of changes will be there in the given data, and you need to find out the values for this. Okay. So next part, the angle of action. Okay. So angle of action is nothing but that can be calculated arc of contact divided by the radius. So first we are taken for the pinion there. So that is for the delta p, if you take it arc of contact by small r, so 42.31 divided by 92. So you get in radians 0.46 radians, and if you convert in the angle, so you get 26.3 degrees. Then the arc of contact for the divided by r for the angle of action for the gear delta g. So same way we use for the gear part. So this you get around 0.1856 radians or 10.63 degrees. Okay. So just confirm the answers whether you are getting the same answers.
Hello, sir.
Yes.
Sir, we can keep it answer in a degree or radians, any one form, no, sir, right?
Degree, angle of action, angle you can calculate in degree. Radians also okay, but if you show the answer in degree, okay.
Okay, sir.
Getting the same answer or different answer?
Yes, sir. Getting, sir, same answers.
Okay. So like this angle of action can be calculated. Next part, yes, I had told someone to calculate. Yes, can you tell the answer? Yes, Mohammed Jafar. Mohammed, I think Jafar, I told you
Yes.
to yes, tell the answer. Have you solved it?
Sir, no, sir. I have just copied the data, sir.
You would be fast.
Sir, I am actually unable to solve, sir. I missed the previous class, sir.
Always, that's why I told you, if you regularly come attend the class, then only you will be able to solve the problems. If you miss one class in between, everything will be discontinued, because everything is continued. So you can see the depth of problem one by one when you are going daily. Automatically some changes are there, and directly
Yes,
if you
sir.
come to this problem, you will not understand anything. That's why you should attempt the theory class also, how the equation is being derived from the derivation. You will not understand the concept only if you directly come with this problem. Attend the classes. Okay, next third part. So what is asked here in the question? Just see. So this
No,
is
sir,
new
now
part.
will be regular, sir.
Okay. So new thing, sliding velocity by rolling velocity is asked in the question, and there are three cases for this. So be careful here. Just look here. So they have asked for beginning of contact, then the pitch point, and then end of contact. So three different cases are there. So sliding to rolling velocity means the sliding velocity formula already know, that is nothing but omega p plus omega g, that is two addition of the two angular velocities multiplied by path of approach. So this is known to you, and rolling velocity is nothing but the pitch time velocity. So that is omega p into r. Okay. So once you substitute these values, you get the answer for sliding velocity divided by rolling velocity. So in the first case, they are told to calculate at the beginning of contact. So at the beginning of contact means at the start of the consideration. So here you need to use this ratio. So already you know gear ratio is given to you. So you can take this ratio and then substitute the values. So omega g is nothing but 23/57 times of omega p, the ratio. So from there you get the answer as 0.32. Now what will happen at the second case? So at the pitch point what will happen? Automatically the path of approach will not be considered. Means at the pitch point what will be there? It will be exactly 0. So there the value will be 0. So once you get 0 means the total value also will be 0 only. Okay. So second case at the pitch point will be getting the answer as 0, because at this point there will not be any contact. So exactly 0. Next, the third case, they are told at the end of contact. So at the end of contact you have to use the path of recess, the remaining part. So first path of approach, and at the pitch point you take it as 0, and then path of recess. So if you take a path of recess at 18.79 and you get the answer as 0.287. Okay. So check these answers, 0.320 and 0.287. Anyone getting the answer here?
Yes, sir. Getting, sir, near to that.
Okay. So solve this problem. Okay, same way how you have done in last class. So you need to solve this. So read the cases correctly and solve this, then only you will understand. Okay, so we'll move to next one. So next problem, you can see two 20-degree gears have a module pitch of 4 mm, and the number of teeth on gears 1 and 2 are 40 and 24 respectively. So number of teeth is given, and if gear 2 rotates at 600 rpm, means second gear the speed is given, you have to determine the velocity of sliding when the contact is at the tip of the tooth of gear, and you have to take the addendum equal to 1 module, and finally again you have to find out the maximum velocity of sliding. So try to solve this problem. So first you calculate the radius. So addendum 1 module means directly 4 mm. So radius 80 mm, then adding 4 to that addendum circle radius 84 mm, then small r you get 48 mm, then RA you get 52 mm, and with the ratio of the gear ratio, it is speed is given 600 for one thing. So from there you can calculate the RPM for the gear. So you get the speed of the gear as 360 RPM. Then let pinion, that is gear 2, be the driver, and the tip of the driving wheel is in contact with a tooth of the driven wheel at the end of engagement. So thus it is required to find the path of recess, which is obtained from the dimension of the driving wheel. So you know the path of recess formula. So substitute the values of path of recess, and you get path of recess as 9.458, and the velocity of sliding for this it will be omega p plus omega g into path of recess. So only you have to take the path of recess because we have taken lead pinion, that is gear to be the driver. So that if the type of the driving wheel is in contact with the tooth of the driven wheel, so at the end of the engagement you will be getting this path of recess. So path of recess is 9.458, and if you substitute the formula, you finally will get 57049 millimeter per minute, or you get 950.8 millimeter per second. Okay, so we'll be getting this answer. Anyone has got this answer?
Yes, sir. Got, sir.
Okay, so you have considered here pinion be the driver. Okay, if you change it automatically, you may get a different consideration. So in the case of gear wheel is the driver. Okay, the tip of the pinion will be in contact with the flank of the tooth of the gear wheel at the beginning of the contact, and thus in this case what will happen, to find the distance of the point of contact from the pitch point, that is the path of approach. So the path of approach is found from the dimensions of the driven wheel, which is again the pinion. So the path of approach will be again same thing, that is 9.458 only. So the velocity of sliding will be again same as that value what you have taken, so that is 950.8 millimeter per second. So thus it is the immaterial whether the driver is the gear wheel or the pinion. So the velocity of sliding is the same, and when the contact is at the tip of the pinion. So even if you take any case, it will be nothing but because the velocity of the sliding is the same when the contact is at the tip of the pinion. So next the case, the maximum velocity of sliding, that will depend upon the larger path, considering any of the wheels to be the driver. So considering the pinion to be the driver, so you get path of recess as 9.458, and then you get path of approach as 10.117 mm, and this is the only path of recess if the wheel becomes the driver. So this is the maximum path of velocity of sliding, that is maximum path is 10.117. So if you consider the maximum velocity of sliding for this, so it becomes 1017.1 millimeter per second. So solve this problem as assignment. There are total 5 questions here. 1, 2, 3, 4, 5. Okay, similar to the things what we have done till now. Okay, so practice these problems. Okay.